Are you guys ready?
Yeah.
All right, so this is supposed to be fun, a little bit educational. I'm really excited to introduce this. So, blockchain. Some of you may have heard of it before, and some may have not.
In front of you.
Does this work?
Oh.
Am I gonna have to do? There we go. Okay. So the agenda would be just a quick introduction of what blockchain is. We're going to go through the history of trade and trust, and then we're going to go into like what the nuts and bolts of what blockchain is, some mechanics, and then how we can use it, how we should be excited about it, and then high fives. So let's get started. So the textbook definition is a distributed database that maintains a continuously growing list of ordered records called blocks. But really, do we know what that means at all? So, of course not. It's very foreign, even to me. It took a long time for me to figure that out. So, there are two really important things we need to address first. And I thought I'd show a picture of Muhammad Yunus because he's the father of microcredit and helped people all around the world basically build security around finances when they had no money or access to banking systems. So, the first item is trust. Trust is super important. It brings us together. It allows us to purchase things, trust brands, individuals, and it brings countries together. Without trust, we really can't do much. The other component is trade. So without trust, you can't do trade because you need two individual parties that are willing to fulfill the contract or agreement that's been made. So keep those two things in mind because they're super important as we go forward. Because as we look through all of history, those two items generally rule over how all things occur. So, how do we exchange value? Because in current day, we do it with our computers, we do it with our credit cards. But to really understand the paradigm shift that blockchain is going to have on our generation and the future of the world, we need to understand where we started. So let's go back a couple hundred years, 500 to be exact. So we used to trade by ships circumnavigating the globe to bring goods and valuable items from country to country. If it were gold or silver, if it were animals, if it were food and textiles. The problem with that is we had to trust that the person that was going to be bringing those goods to our country was actually going to bring what they said they were going to bring. We used to ship ice from Boston to India, but who knows what would actually show up when it got there. As time went on, we came up with more verbal agreements to guarantee the product that would arrive. But still, if we look back at history, there's conflict and wars because those contracts were never really fulfilled the way they were guaranteed. Don Tapscott is a world-renowned visionary for digital technologies and blockchain, and he puts a lot of emphasis on how technology has allowed us to advance ourselves so much, but it's really only helped a few select people do that. And that's kind of a problem. How can we create equality through the technology rather than separation? And in current day, we have all these huge brands and businesses that we trust, and people and corporations. But it's really hard to know whether or not do they have our best interests in mind, or are they trying to accomplish their own agenda? So how do we know who to trust? Who's going to protect me in a world of no privacy or secrecy? How do we really know our best interests are kept in mind? And that's why blockchain is here. So now we're going to go into what blockchain really means and how is it going to do that for us. One thing I should mention before I go into this example is some people are thinking that blockchain is the biggest technology arrival since the internet. And some people are saying even greater than the internet. So it's weird that it hasn't become like a household term yet. So think about how maps work. Hundreds and thousands of years ago, when explorers would travel across countries and around the world, they'd create a new map. And so you have millions of people around the world creating their own map. But if we put them on top of each other, are they the same? They're not. They're completely different. But why do we trust a single map? Google Maps. Because we know they validated their information. The Google map that we look at in the US versus in China and Australia, we know that information is accurate. So think of how if we were to look to one source of truth and we wanted to have one map to trust what information is, think of that with finance. if you went to a bank and it had different listings of transactions, and then you went to a separate bank and those transactions were different, could you trust that bank? Probably not. But today, blockchain allows us to take that information and make sure it's exactly the same across every single location that is accessed. So that one source of truth is super important. These are two famous blockchain supporters, Lewis and Clark. I'm sure they would have wished they could have had it. And so, as I mentioned before, with that map example, if everyone had the correct map, they wouldn't be questioning each other whether or not they knew where certain things were thousands of years ago, because there would be that one source of truth. But when you have that source of truth, people trust each other, and they trust that this person's information is correct, and this person's information is correct. And what that does is it allows us to make sure that if someone comes into the network with new information, we can validate if it's accurate or not. And I'll get into what that actually means. So this is basically how networks work today. Centralized networks is how we would envision a bank. So you go to a bank, you do a transaction, you trust that bank because when you make a payment, they're going to update that transaction in their ledger. They may have banks located all over the country, and when I go into Wells Fargo or JP Morgan Chase, every single bank is going to have the same information, hopefully. But why is that a problem? Because what happens when you want to conduct business in a different country where that bank doesn't exist? You have to reprove that you are a trusted party. Or what if you live in a country where they have no system that protects you if you own a piece of property, or if you're in a business in a communist country where the government can change that information whenever they want? And that is the biggest problem that the world faces today, is property, title ownership, record keeping. When a country overthrows another country, they inherit anything they want rather than trusting the documentation that proves that this individual owns this property. So that's the problem with centralized and decentralized networks, and that's where we go to distributed. So what distributed networks mean, imagine every single one of these nodes as that map. And all these nodes have the exact same map, the exact same information. So that if this person talks to this person and they can make sure if this person made any changes to that map, they all know that is incorrect. Another thing that I should mention is all of these nodes, if there's ever a change, they get updated together. And so that all the information is exactly the same. However, there is a driver that motivates that change, and I'll explain what that means. So this is where it gets a little bit complicated, but I wanted to address it just for anyone who wants to understand the mechanics behind blockchain. Because everyone's probably wondering, well, if there's a network information and every single node has a copy of that information, who's causing those changes to happen? And how do we make sure that those changes are secured? So this is a block, all right? So you have the number of the block, you have the nonce, which is just a unique number, and I'll explain what that is, and then you have your data. The great thing today with data is we can actually put inside the entire Library of Congress in one single block because it's just information. We've created technologies to reduce that information to such a small amount we can save it basically anywhere. And then we have a hash. This is the fingerprint of this block. When you take this data and you cryptographically save it, it creates a hash string of digits that basically identifies what this block is. I know it's kind of confusing. It took me a while to figure this out. And the nonce is the number that you enter inside this block to get this number. We actually will not know what that number is until we try and try and try again. So we could put a 1 in. Does the 1 give us this number? No, it doesn't. There's a 2, and then we go all the way up to 72,608. So this isn't super important, but just so you understand what that means, this is what's really important. So how a blockchain works is you have one block with whatever information's in here. Maybe it's like Mike's birth certificate. That's super important. We don't want anyone to tamper with that. So we're going to save that in a block. Mike is going to have this hash number. Only he has that. However, what if Mike has another piece of personal information, and that gets saved into the second block? And then another piece of important information, like his driver's license. That's in the third block. So what's unique about this blockchain is this first block hash number gets saved into the next block. And that keeps happening. So what does that mean? If someone tries to tamper with this single block, every single block in succession is locked completely until the network can actually look at this blockchain and revalidate what the correct information is. So that's important because if you have 1 million blocks and someone tampers with the second one, all of them are locked, basically. So if you can think about that in banking, if someone hacks Amazon or Yahoo, what they can do is as soon as anything is tampered with, the network completely isolates that chain of information and nothing can be changed. Because the system won't actually let those changes occur until the entire network validates what the truth is. So that's the beauty of blockchain. And so you're probably wondering, like, who's doing that? Who's making sure that these changes are accurate? And why would they want to do that? Because you'd be having to go through millions of different chains of numbers. The math for this is incredibly complicated. Well, there's an outrageous reward for the people that we call miners. So miners are basically computer banks that are doing lots of math to solve problems in the blockchain. And so when we have, let's say, 10 blocks, and a new piece of information is going to be added to the blockchain, in order for that block to be added, you have to solve for that nonce number, that random number we want to put in the block to give us that hash, that cryptographic hash string. And when you solve that math problem, whoever miner it is around the world, you get $11,185 every 10 minutes. So you can make up to $1 million in a day, and it's free. All you need, all you, and that's the beauty of the blockchain is there is an incredible financial reward for people that are trying to secure information on the blockchain. Just because you have a computer on that has the power to solve for these blocks, you can mine for blocks. So many years ago, when mining just became like a hobbyist thing, you could do it on your laptop, you might make $1 or $2. Now it's become, if you mine for a block, it's 9,900 and change for a single Bitcoin, when it used to be like $1 or $2. So why is that important? If you're trying to hack this network, you have to hack every single block on every single computer in the entire world simultaneously and change that information without the network knowing that it's happening. And so that's why it's completely infallible. And you can just imagine if you're trying to convince 5,618 nodes, which are the groupings of computers that are trying to keep it safe, they're going to make sure they do everything to make sure that's not going to happen. So that's why it's immensely secure and it's widespread. So that copy of information is saved on every single node, on every single computer, all over the world. Since it's fully distributed, it's fully open source to anyone. So what are some of the use cases? Like all this cool, strange, technical blockchain information, like what does it do for me? Like how is it actually impacting my life? And I think that's a lot of people wonder. They hear Bitcoin, Ethereum, and Pocketcoin and all these other blockchain technologies, but now people are coming up with really unique ways to apply them to everyday life. And here are some categories I came up with. You have creative works of art, economic, business, and civil and government. So there are people building technologies that allow us to secure our music, our art, our film, the way we vote, our identification, stocks and bonds. So now in the future, it may be possible if you create a track or a movie, you can actually put it on the internet on a blockchain, which is basically just a website, and every time someone plays that track, uses a clip out of your movie, you can actually make money. And that all happens automatically. because you can design the rights to your piece of intellectual property so it executes when anyone accesses that piece of information. And so I'll show you a couple examples of people that are doing that right now. Oh, I should also mention a huge one here is voting. Because today we have paper voting. Why? It is so stupid. So you can transfer $1 million with Bitcoin, but we can't vote. We can't vote with a computer. Like, it doesn't make any sense. So that's, I think, a big thing we'll probably see in the future is you can't tamper with the blockchain. But a lot of people are saying in the industry that voting hasn't become put on a blockchain yet because once you do that, you can't change it. So there's a lot of belief that a lot of political parties in the world are manipulating the voting system. Because if you look at voting in non-developed countries, it's usually a landslide, where most of the voting population will usually vote against the dictator, but he may win already, and they'll just kind of cook the books. So once you do this, basically politicians have to tell the truth. So that'll be great, and I'm looking forward to that. Bitcoin, we've obviously heard of that. The most valuable cryptocurrency in the history of the world. It's the only currency that's been able to rise in value from a couple of cents to almost $1,000 in under 2 decades. So, and a currency that you can use to buy products all over the world, which I think we've probably all heard of. So that's where blockchain is being used.
So wait, I'm sorry, real quick. So that's a legit currency?
It's a legit currency. You can get a card. You can get an app on your phone, and you can use it to buy pretty much anything.
You can pay in
Yes.
Bitcoins.
Yes, you can. They actually have Bitcoin vending machines now.
So what do they look like? Do they look like that letter B and a bunch of gold coins?
No,
Or what
it's
is it?
all like.
It's all digital.
It's digital.
Yeah, that would be pretty funny if you could be carrying around a bunch of blue gold
Well,
coins,
you said vending machine, sounds like
like where you can tap
stacks
into.
rolled up.
Well, like you can go to a bank and somehow exchange bitcoins for dollars.
So certain banks, that's what a lot of these Bitcoin kiosks that I'm trying to think of some vendors. A lot of them are in Europe. I can't think of a Coin Wallet, I think. So I don't think a lot of consumer banks, like big box banks, are really using it. I've spoke to a few, and the problem with Bitcoin and the traditional banking network is banks make money because they control where your money goes. So JP Morgan Chase, if they have trillions of dollars in their operating budget or their credit balance, they decide who gets to trade with that money. When you trade on a blockchain, it's accessible to the whole world. So if you went to, like, let's say Slovenia and there wasn't a Chase bank there, Chase can't control what you do with your money. So Chase wants to make sure that wherever you use their card, they control where that credit circulates. What blockchain does is it allows you to take your money anywhere. You're not restricted by anything. Only thing you need as of it is a internet connection. And so the beauty of that is, what if someone who made $2 a day had a Bitcoin wallet? They could spend that money, save that money anywhere. They have an internet connection. And so what that does is that democratizes the world. So
Someone who accepts Bitcoin.
that's true, yeah. But if they have an internet connection, they could do that. So essentially, if you had a phone, and that's what a lot of these developing countries are doing, because if you think of what it costs to transfer money from Phoenix, Arizona to London, you might take you a week and a half. You're going to pay probably just under 10% in the transfer fees. Bitcoin, to transfer it, it costs the same amount to send an email, which is like, I think, a penny for 3 million transfers. So are the banks going to give us that savings? Probably not. So that's what they're trying to figure out, how to use blockchain, but the inherent design of the technology is to basically create equality, not control. And so I think we're going to see a huge change in all industries where people are going to start having control over their identity, control over all their information, their finances. And some people are talking about how you can actually program use rights to your health data so that if you want to allow an app to use your health information, you could make money. And it would be anonymous. So think about that. Like, we have, how many apps do we use? What if you made money whenever you used an app versus the other way around? So they would still make money with ads, but you could still make money based on the fact they're using your personal information.
Are you going to cover the downsides of blockchain and Bitcoin?
We'll maybe get to that. There are.
Oh, there are.
Perfect. Yeah, there are. But I think any technology in its infancy, it's going to have its
Serious
bumps. So, like I just mentioned, smart contracts. A huge thing, like I talked about, was with titles. Let's say you're a farmer in Honduras, and you've owned this property for several decades and generations, but you don't have the government doesn't track that. What companies like smart contracts are doing is they're trying to help people put these property titles on the blockchain so it's protected.